So now that we know or we remember what an exponential function is, we want to explore what is a logarithmic function. So this is probably the first time that we're ever even seeing this or hearing about this type of a function. But the good thing about it is that I can easily relate it to an exponential function because they are inverses. Remember, an inverse means that all I'm going to do simply is switch the function, okay? What I mean by switch, everything that we know about the x's, we now know about the y's, and vice versa. Everything we know about the y's, we now know about the x's, all right? So let's review what an exponential function of y equals 2x would look like. So it's that red graph you see up there. One thing that we would know about this graph is that it's got a y-intercept of 1, right? That's what we would see on that table. It would not have an x-intercept. The domain is all real numbers. That's just another way to write all real numbers. We could write it as negative infinity to infinity if we wanted, all right? The range is going to be 0 to infinity. So I'm just going to go ahead and write on there just to clarify what those look like. I don't want you to get confused with the notation here, okay? We also know that it has a horizontal asymptote at y equals 0. We know that our table of values would be negative 1, 1 over 2, 0, 1, and 1, 2, right? So now all we need to do to find the logarithmic function is to reflect it over the line y equals x. We're going to find the inverse, so we are switching everything. So let's just look at this by switching, okay? What I mean by that is I want to look at everything that the exponential had and reverse it. For example, the first statement, there is a y-intercept of 1. In a log, there is no y-intercept. In an exponential, there's no x-intercept. And in a log, the x-intercept is 1. So I notice that those things have been switched. Okay, so the x-intercept is now the 1 instead of the y-intercept, and the no-intercept now goes to the y instead of the x. So I'm just switching those. All right, the next thing I notice is my domain and range. Okay, so my domain this time is 0 to infinity, and my range is negative infinity to infinity. That is a direct switch from what we had in the exponential. All right, another switch that I see is this idea of my asymptote. So instead of a horizontal asymptote, I now have a vertical asymptote. Instead of y equaling 0, the x is equal to 0. Okay. The next thing that I'm going to do is I'm going to switch the table of values. Okay, what I mean by that is what you notice here, I've got my x and my y's are literally switching sides. So my y's become my x's and my x's become our y's. All right, so everything is switched. So now that we have kind of discovered where this whole idea of a logarithmic function came from, it came from an exponential function taking the inverse. So now let's just look at what does that mean that a logarithmic function has? What are its key features? So we talked about them on the page before, but let's just look at it. The domain being from 0 to infinity. The range now being my all real numbers. My intercept is now an x-intercept. It's 1, 0. The asymptote is now a vertical asymptote. It's at x equals 0. My table of values now switched, being 1 over b, common negative 1. 1, 0. b, 1. All right, so all of those things have now been switched. Right, and when I look at the graph of a log function, one thing I notice here, we've kind of highlighted in blue, is that my asymptote is now going up and down, and my function will kind of wave off to the right-hand side. All right, so you can see my function there in the red. As I get close to the vertical asymptote, I'm going to approach either positive or negative infinity, and then I'm going to go off over there to my positive infinity since my domain goes from 0 to infinity. All right, so now that we know about a log function, we want to transform it. It's great to know what the parent is, but if we can't move it around, we're not doing much with that function. So now we want to look at, okay, how can I move this same log function up, down, right, left, stretch, shrink, reflect, all of that good stuff, okay? So when we look at this function, okay, I've kind of got them all a little bit outlined here, but let's look at the summary, okay? Same placement as before. The A is going to stretch, shrink, and reflect. Remember, those are all vertical motions. Okay, so all of these are going to be vertical stretch, vertical shrink, vertical reflecting, okay, meaning over the x-axis. Then I'm going to have my base. It's still that little baby b there, okay? So I know it's really, really tiny, okay? But that is our base, just like we had a base in the exponential function. Then we have our h, how we're moving right and left. Remember, it's opposite of what you think still. We have our k, how are we moving up and down? It's exactly what you think. All right, so same transformations, same location, if you will. The h goes inside with the x, the k is on the outside added or subtracted, the a is being multiplied in front. Okay, so let's see what that does now to our key features. Right, so now that we care about the domain, remember the domain is what was 0 to infinity. Think about how the x values, which our domain is, how can an x value move? An x value can move to the left and to the right. Therefore, our domain will be affected by the h value, okay? So this h value this time is probably one of the more important pieces because it's going to tell us about our domain, which will go straight along with my vertical asymptote, okay? Just like last time, the range and the horizontal asymptote went together. This time, the domain and the vertical asymptote will go together, okay? The range of a log is always all real numbers this time. Vertical asymptote comes from that how are we moving right and left. Now, here's where a lot of people get mixed up on a log function. Because if I look at an equation, okay, I might have log base b x plus 2. That is really moving to the left 2. Therefore, my vertical asymptote would be at negative 2. So I have to remember, since h is opposite of what we think, that when I go to write the domain and the vertical asymptote, that h is opposite of what we think. So we have to remember that, okay? I'm going to get the table of values the same way, but they are coming from different numbers, meaning that, remember, we switched the x and the y, but I will add, subtract, do all that transforming the same way. Okay, so let's see what that might look like played out here. All right, so let's start off nice and easy again. We are just going to look at the key elements from an equation and a graph, and then we'll look at actually graphing. Okay, so let's look at this first example. We want to find the domain, the range, and the vertical asymptote. Now, again, at the end of this, I hope that we realize that the range will always be all real numbers for our log function, okay? Last time, the domain of an exponential was all real numbers. Now, the range of a log is all real numbers. Okay, so we're going to start off with our domain. Our domain comes directly from that vertical asymptote, which we will find inside of our function with our h, which is our h, so our negative 3 there. Our negative 3 means that it's actually going to be moving to the right 3, which means that our vertical asymptote will be at x equals 3. Okay, that means, because we did not do any kind of reflection here, that means that our domain will be from 3 to infinity. Okay, now our range, hopefully we know by the end of this, will always be that all real numbers. So negative infinity to infinity. Okay, let's look at our next one. I'm going to start off with my domain, which will come directly from that vertical asymptote, which means I need to look inside the function. That plus 1 means that I'm going to be moving to the left 1, which means that my vertical asymptote will now be x equals negative 1, making my domain negative 1 to infinity. My range will be always all real numbers. Okay, hopefully we're kind of getting the idea here. So I'm going to start on my next one, my domain, which comes from the vertical asymptote. I'm going to look inside my function, but I notice there's nothing inside the function here, right? It's just an x. That plus 1 is on the outside. I'll know that it's inside the function because I'll have parentheses, okay? So there's nothing inside the function, which means that I go back to the parent, which is x equaling 0. So my domain would be from 0 to infinity. My range will always be those all real numbers. Okay? So let's look at what that would look like from a graph now. Okay? Looking at my first graph, to find my domain, I'm going to take that directly from my vertical asymptote. All right, that is going to come from where am I vertically leveling off? Okay, so if I follow this graph, I notice that I'm kind of approaching negative infinity right there at that y-axis, which means that the asymptote is going to be x equals 0. Right, so since my vertical asymptote is there at x equals 0, that's where I'm vertically approaching infinity or negative infinity, my domain is going to be 0 to infinity. Okay, I can also look at the idea that I'm going from the x value of 0 here off in a positive infinity direction. Okay, remember I'm never going to actually be that 0 value. That's why we put the parenthesis. In our range, either I can look at it from the graph that I've got an arrow at the bottom and an arrow eventually approaching off to infinity, or I can remember that my range is always negative infinity to infinity. Okay, let's look at our next one. So they were so kind. They already drew this vertical asymptote for me. Okay, they don't have to. We noticed in the last one that they did not already draw it. If they do, I will find, again, where am I vertically approaching either positive or negative infinity. So I notice I'm approaching here at this negative 2. So that means my x is going to equal negative 2 for that vertical asymptote. I'm going off to in a positive infinity direction, so it will be negative 2 to infinity. My range, all real numbers. All right, now that I think we've kind of got the idea of being able to identify those key features, let's go that extra step and try to actually graph a log function. Now I'm going to start the same way that we did before. I'm going to identify these key features. So let's go ahead and get those written down. I want to find my domain. I want to find my range. I want to find my vertical asymptote. I'm going to abbreviate here. And then to be able to graph, I'm going to need to find my table of values. Okay, so let's look at each one of those pieces here. To find the domain, remember the domain and the vertical asymptote come from whatever is inside. So I notice that this function is moving here to the right 5. So my vertical asymptote is going to be at x equals 5. My domain will be from 5 to infinity. My range, all real numbers. Okay, hopefully we've got that and we are ready to go on identifying those elements. Okay, now what I need to do is figure out, well, where are these points going to come from? So I already know that I'm going to the right 5, which means I'm going to be adding 5 to my x values. The next thing I notice, I have that plus 4, which means I'm going to be going up 4. So I need to be adding 4 to my y values. Okay, so we need to have our base values to start from. On a log function, I start from 1 over the base, which is 2, comma, negative 1. 1, comma, 0. And the base, which is 2, comma 1. So those are what I'm going to start with, and then I'm going to transform the x's by adding 5, and I'm going to transform the y's by adding 4. So let's do those transformations and see what values we actually have. So I'm just going to use a decimal here. I'm going to have 5.5, comma 3. I'm going to have 6, oh my gosh, comma 4. And then I'm going to have 7, comma 5. So now I can see my ordered pairs here. Just write them down. I'm going to go graph these points on my graph over here. And as I do this, remember, I'm going to approach that now vertical asymptote as I go to graph it. I'm going to approach vertically this asymptote. So let me finish my little points here. 6, 4, 7, 5. I'm going to vertically approach 5. So it looks something like that. All right. Now, let's look at another function here. Let's look at another example. I want to find my domain. I'm just going to abbreviate here. I'm going to find my range. I'm going to find my vertical asymptote. Then I'm going to come over here and I'm going to find my table of values. All right, so looking at our function, the domain and the vertical asymptote come from inside our function. We have a +1, which means we're moving to the left 1. So my vertical asymptote is going to be at -1. I'm going to go from -1 to infinity for that domain. My range is going to be all real numbers. Okay. I'm going to come over here to my table and see how my transformations now affect my table. So left 1 means I'm going to subtract 1 from my x's, And then I see I have this 3 out in front. 3 is being multiplied vertically, which means I'm going to stretch this function by 3 vertically. So if I think about the vertical motion, vertically is going to be my y's. So I'm going to actually need to multiply 3 in front of all of my y's. All right? So let's do that. We start off with our points 1 over the base, which our base is 2, comma -1. 1, 0, the base, which is 2, comma 1. All right? Now I'm going to transform my function. So I'm going to subtract 1 from all my x's. I'm going to multiply by 3 all of my y's. Okay, so let's see what that makes my points to be. So I'm going to have -1/2, comma, -3. I'm going to have 0, comma, 0. I'm going to have 1, comma, 3. So let me write those out. I'm going to use a decimal for that first one. It doesn't really matter what you use. Okay, so here's going to be my 3 points. And as I graph them, I'm going to approach vertically -1. Okay, so let's do it. I'm going to go 0.5, -3, 0, 0, and 1, 3. So I've got those 3 points. I'm going to approach -1. And the way I can kind of see that stretch, you notice in my first example, those 3 dots were really close together, those 3 points. These 3 points are kind of stretched out from each other. So I can see that vertical stretch occurring. Log, in general, has 2 basic forms. A log with no base is known as a log base 10. The easiest way that I remember that is that the log literally looks like a 10G. So the way I remember that log without a base, so if they put no number here, I know that that's really a log with a base 10. They will not ever put a 10 there. I just have to know it. Okay, kind of like a square root. They don't put a little 2 there, but I just know that it is a square root. Okay, so just like that, I know that a log with no base has an implied base of 10. Now, the second representation of a log function, the natural log, you'll look at that more in pre-cal and things like that. So the one we want to focus on is just having a log with a base 10. All right, so let's look at an example just to make sure, just refresh, make sure we know what's going on. Let's look at an example with that base 10. So we'll do one more here. Nothing changes except for I just have to know that the base is a 10. All right, so we're going to start off with our domain, our range, our vertical asymptote. We're going to get our table of values, and then we'll go graph. All right, so domain and vertical asymptote. Again, let's do it together. We're going to find it from inside the function. This function is moving to the left 5. So I will have a x equals -5 for my vertical asymptote. My domain will be from -5 to infinity. My range is that all real numbers. Okay, I'm going to look at my transformations to help me graph this. I already know that it's moving left 5, which means I'm going to have -5 for my x's. I have a -3 here on the outside, which means it's going to move down 3. So I'm going to subtract 3 from my y's. Let's go build our original points. 1 over the base. This is the only part that I'm going to now have to know. No base here means that it's a 10. So it's going to be 1 over 10, comma, -1, 1, 0, and then the base, which is that 10, comma 1. All right. We're going to take those, we're going to transform them. I'm going to subtract 5 from those x's. So -5, -5, -5. I'm going to subtract 3 from my y's now. -3. All right, so now let's see what that gives me for my new points. All right, so I'm going to have 1/10 is really 0.1. So I'm going to have -4.9. Again, I'm going to use a decimal here, comma, -4. I'm going to have -4, comma, -3. I'm going to have 5, comma, -2. So let me write those ordered pairs there so we can see them. And last one, 5, -2. So let's go graph those points. I'm going to go to -4.9, -4. Then I'm going to go to -4, -3. Then I'm going to go to 5, -2. As I graph these, I'm going to approach that vertical asymptote at -5. So it would look something like this. So now hopefully we are able to now see what a logarithmic function looks like, how it's graphed, what the equation looks like, how to find the key features and elements from a graph and an equation.